Welcome everyone. I am very pleased I'm allowed to have a short presentation here. And my colleague Gunnar Hedin presented more of the basic technology, so I thought that it was more interested to tell you a little about what examples we have, where we're using our fiber Bragg racing and our systems. Very short about Proximion. So we at least say we are world leader in production of advanced fiber Bragg ratings, and we started with telecom. So that there you need very high quality of the ratings, and then we started with sensor about 10 years ago. We've been in the business for almost 30 years. So I would say we're not a startup anymore. We have quite good facilities with 2,000 square meters of clean room. You see the nice building here to the left. And we use a specific unique way to write the fiber Bragg ratings. We are not using any face mask, so we don't have any of those problems. One of our specialties is to manufacture very long, continuous short ratings without any phase errors. So we make them up to 20 meters. They are very useful in telecom. They can also be used for sensing, but in most cases, we use discrete sensors for discrete gratings for sensing, but we of course make multiple of them in the same fiber. So we have delivered a lot of fiber Bragg ratings. We are also a fully owned subsidiary of the Hexatronic Group, which is a quite big company. So that gives us I mean, because in many cases, if you're a supplier, you need to be a long-term supplier. So that's good thing. And we are situated in Sweden, here in Kista, and sitting in the office. And so I guess that gives somewhere about 30 people in the company. So very short, this is a fantastic illustration, just to give an idea of what the system is for us. So we make the sensor gratings, but in our fiber, in our own facility here, we have our own developed machines. But then also we need to put it in some package that's suitable for the application. We need to supply cabling that works in many times quite tough environment. And then we need an integrator. This one is also developed by us. And finally, and that's not the least. We need to make out software to present the data to the customer interface to other system. So it's and we are quite vertically integrated as a supplier. And in some cases, we only deliver fibers with sensors on it. In other cases, we deliver a complete system. Our experience is that in an industrial environment, the customers they are most interested in this case get temperatures. And of course, they say it's fancy with fiber optics, but in the end, they don't care too much about the technology. So we supply a solution where we optimize the fiber gratings to the integrator, and then of course have some software that interfaces well with the customer system. And depending on the application, you could have quite different requirement on the integrator. So we also source other integrators. So if someone has an integrator to sell to us, we are interested. And also tunable lasers are of interest. So one example here is we spend a lot of time on is to develop sensors for airborne applications. This is one thing is to develop the technology. Another thing is to really get it certified for use in an aircraft. And a common problem in most aircraft is that you have a bleed air system for supplying power for the de-icing and for air conditioning in the airplane. And so it's a power source that you take from the jet engines, from the compressor stage. But as you have a lot of moving joints and so on, you are a bit afraid that you should get a leak. So you typically have a bleed air overheat detection system. And now we have a supplying this as a fiber optic solutions, and there's plenty of this piping inside the plane. So and you want to monitor it almost everywhere. So that means you need to supply like 6,000 sensor points that is distributed over 70 meters. So we need to make a lot of gratings. And also important here is that we cannot supply individual calibration with each fiber cable we supply. They need to be identical in wavelength. So that's also quite I would say a challenge, but we have been able to meet that. So we manufacture and we also developed these sensor gratings. And we also helped our customer with the design of the optical part of the interrogator. So we also try to be a good supplier in that way to also supply some knowledge. Second application where we have a lot of customers is in continuous steel casting. I guess most of you don't know too much about continuous steel casting, but that's the dominated way of casting steel. And this is like in huge steel plants, where here in the case, this is from an example from in Sweden, where you have 180 tons of liquid steel coming in, and then you allow that to flow into first the thunders and then here into the mold. You see my arrow, hope. And these are 4 copper plates that are cooled with a lot of water, and then you will have the steel that will be will not what's that? It will get solidify here, at least at the surface, with the rate the steel is come out with the rate of 1 to 3 meters per minute, and then it goes down here, and it's like this is maybe 200 millimeters width here, and then it's in the depth direction, maybe it's up to 2 meters. So this is big. But important here is a critical stage here is the solidification, because that can affect the quality. And if you're unlucky, also you can get that you get a stuck here of the surface of the steel, and then you can get a breakout where you have steel flowing all over here, and that ends up with quite expensive because it's a bit tricky to remove solidified steel over all these rollers and equipment here. So that's important to keep track of the temperature in these copper plates. And that you usually use to do by thermocouples, but they are you can have very limited number of thermocouples, maybe 16 on the mold plate. But we instead have fiber that are vertical, mounted into drilled holes in the copper plate. And each sensor then could have maybe 50 to 75 individual sensor points. So and then you have this in all the plates in most cases. And we also did the first installation in 2014. So this is quite mature now. And in that case, we have 2,660 sensors. So you get like a thermal map here on the display. And of course, the logical practical thing to have these cables that should withstand tough environment. And we also need a very reliable interrogator here that should be working for a long time without any problems. So just this is an example of a real copper plate. So this is maybe, I guess, 800 millimeters high or something similar to that. And you also see the optical cabling here. It's quite tough. And also you have expanded beam connectors here because these are handled by the operators in the steel plant. So they, it's not, you should be able to handle the dust environment and people that are a bit rough with the equipment, but it works very well, actually. This is just an example here of what you can see from using. So you see this thermal map here. It's about 220 degrees Celsius here, and you see so that now this is accelerated in time, but you see that you have problems here when the solidification moves around, and this could be a case where you could have like breakout, for instance. And also, you think steel is one thing, but there are too many different steel grades, and some are very difficult to cast. So there's a very big interest here, because if you just can improve the quality a little in the casting, that's the most critical stage. That's really worth a lot for the plant. In this case, it was Tata Steel in the Netherlands. Oh. So just what you can find, you can see this temperature variation, and you also see that if you change the casting speed, you can also see how that affects the solidification by monitoring temperature. Very important is the mold powder you put in on top as a lubricant during the casting, and the effect on the temperature. And a common problem is that you get cracks on the surface, and that are quite expensive to remove. And even worse, it might, if you have hot rolling on this, and then you can end up as defects on the final product. And you also use, in many cases, use an electromagnetic brake or electromagnetic stirrer, and they, of course, will affect any electric sensor. So this is good that you can monitor the system while the brake and stirrer is on. That was not possible if you have like a thermocouple. So there's actually still a lot of work going on how to use this data in the best way, but there's a lot of interest, because suddenly they can see what's happening inside the mold. So in general, with the fiber grades, you can do more optimization, and we also add safety, because you can detect these breakouts. And in the end, you want to reduce the cost and energy use, because you don't have to redo, what you say, remelt when it's really goes bad. And also it turns out that this is really robust and reliable. That's very important in the industry. So this was all from me, and thank you for your attention.